Okay, now, so for the introduction of a compound interest is the interest on a loan or deposit that is calculated based on both the initial principal and the accumulated interest from the previous periods. Other than that, compound interest can also be taught as interest on interest, and that will make them some grow at a faster rate than simple interest, which is calculated only on the principal amount.
Okay, now for methodology of compound interest, I will be explaining the basic methodology used in calculating interest, especially in financial contexts like savings or loans. First of all, let's look at the key terms. P stands for original principal, the initial amount of money invested or borrowed. Beside that, we have S, the maturity value or future value, the total amount you will receive at the end of the period. Furthermore, capital letter I is the interest amount, the extra money earned or paid as interest. Next, lowercase I is the interest rate per period, the rate used for each interest calculation period. To calculate it, we use the formula lowercase I equals K per M, where K is the annual interest rate, M is the number of compounding periods in a year. For example, if interest is calculated monthly, then M equals to 12. In addition, we also need to know N, which is the number of interest periods. The formula is N equals M times T, where T is the time in years, M again is the number of periods per year. Finally, with these formulas, we can calculate how much interest will be earned and what the future value will be. Next, let's move on to the formulas used in interest calculation. These are essential when we want to find out how much money we will earn or owe every time. First of all, let's look at the future value formula. Capital letter I equals S minus P. This means capital letter I is the interest amount, next S is the future value or maturity value, and P is the principal, the original amount. So basically, we subtract the original amount from the final amount to find out how much interest was earned. After that, we have the compound interest formula. S equals P open bracket 1 plus lowercase I close bracket the power of n. Let's break this down. S is the future value, then P is the principal, next lowercase I is the interest rate per period, and lastly n is the number of interest periods. This formula helps us calculate how much money will grow when interest is added not just to the principal but also to the interest that's already been earned.
Question 1. A university student deposit 5,000 into ASB at age 21. The annual dividend return is 5% compounded yearly. Then he doesn't touch the money for 10 years. So we want to know how much it becomes when he turns 31. First, let's look at the important values that taken from the question. Okay, P. P is principal amount 5,000. K. Annual interest rate 0.05. T. Time in years 10. Then M. How many the money compound in a year? 1. I. Interest rate per period 0.05. And then N. Total compounding period, which is 10. Now we use the compound interest formula as equal to P open bracket 1 plus I close bracket to the power of n. We substitute the values in the formula, then we calculate all that. So we get the answer is 8,144.47 ringgit. Yeah, that's all.
Problem statement. Question 2. You just had a baby. You need 150,000 ringgit when the baby is 18 years old. The investment account gives 6% interest compounded monthly. The problem is to compare the cost of two plans. Plan A, save one lump sum today using single sum future value, and Plan B, save monthly until the baby is 18 using ordinary annuity future value. So the question is, which one is cheaper to achieve 150,000 ringgit? So for the Plan A, we use compound interest. Given from the text, we get future value S equals 150,000 ringgit, interest rate I equals 0.06 per year, and the number of months is 12 times 18, which equals 216. And the formula S equals P multiplied by open bracket 1 plus I, close bracket raised to the power of n. So now we need to substitute the values. 150,000 equals P multiplied by open bracket 1 plus 0.06 over 12, close bracket, raised to the power of 216. And now we need to calculate growth factor. First, calculate 1 plus 0.06 over 12, raise it to the power of 216, which give approximately 2.936765972. Then just solve for P. So P equals 150,000 divided by 2.936765972. That equals 51,076 ringgit and 59 cents. For Plan B, we use ordinary annuity, and the formula is S equals R multiplied by the fraction of open bracket 1 plus I raised to the power of n minus 1 close bracket divided by I. So next, we need to substitute the values. We got 150,000 equals R multiplied by the fraction of open bracket 1 plus 0.06 over 12 raised to the power of 216 minus 1 close bracket divided by 0.06 over 12. Okay, then we need to calculate the bracket. First, calculate 1 plus 0.06 over 12 and raise it to the power of 216 to get 2.936765972. Subtract 1 to get 1.936765972. And now divide 1.936765972 by 0.06 over 12. That equals 387.3531944. Then divide 150,000 by that value. So now R equals 387 ringgit and 24 cents. So finally, total deposit multiply 387 ringgit and 24 cents by 216 months. That equals 83,643 ringgit and 84 cents. For final comparison, Plan A requires a one-time deposit of 51,076 ringgit and 59 cent. And for Plan B required monthly saving for 387 ringgit and 24 cent for 216 months. The total deposit in Plan B is 83,643 ringgit and 84 cent. Therefore, Plan A is more cheaper to achieve 150,000 ringgit Malaysia.
Okay, now we will proceed to question number 3. A young engineer gets 12,000 ringgit from his first job bonus at age 23. He invests all of it into ASB, which gives 5% compounded annually. After 4 years, at age 27, he adds another 8,000 ringgit into the same ASB account. He plans to keep all the money until age 33. For the question, how much money will he have in his ASB at age 33? So for this question, we will have to use the formula of S equals to P bracket 1 plus I bracket power of N. Step 1. S equals to 12,000 ringgit bracket 1 plus 0.05 over 1 bracket the power of 4. So the total amount will be 14,586 ringgit and 8 cents. Next, we will add 8,000 to the amount that we get earlier to get a new principal for the next 6 years. So the total will be 22,586 ringgit and 8 cents. It will be a new principal for the next 6 years. Okay, for the next step, we will use the same formula as step 1. For this, we will use the new principal, which is 22,586 ringgit and 8 cents. The N will be 6 and the I will be 0.05 over 1, which is the same as the step 1, which is S equals to 22,586 ringgit and 8 cents, bracket 1 plus 0.05 over 1, bracket the power of 6. So the total amount will be 30,267 ringgit and 51 cents. The total amount he will have in his ASB account at age 33 is 30,267 ringgit and 51 cents. Production of annuity. Annuity concepts enable people to plan for the future in terms of investment or savings. For example, financial consultants use annuity calculation to advise clients on suitable investment strategies, such as shop rental, installment payments, or insurance policy. Annuity also is a series of equal payments made at regular intervals over a period of time. These payments are either deposit or paid periodically.
What is S? S is future value of annuity, total savings, and accumulated amount of unpaid payments. What is A? A is present value of annuity, the original loan and initial amount in the savings. What is R? R is amount of the periodic or series payments. N is number of interest periods, and I is interest rate per interest period. Annuity formula have two formula, which is S equal to R bracket 1 plus I and minus I bracket divide by I, and A equal to R bracket 1 minus bracket 1 plus I bracket negative N bracket divide by I. And if we want to find interest earned, we also have the formula, which is I equal to Rn minus A, or I equal to S minus Rn. So we load the problem statement for question 4. You have pituitary and balance 20,000 ringgit. Interest 6% compounded monthly. Repay 7 years. If you pay normal installment, your monthly is 292 ringgit 70 cents. But if you increase payment by 150 ringgit more, so total 442 ringgit 70 cents per month. So the problem is, how many years can you shorten the loan and how much interest you can save? So in this question, we have A, which is 20,000, I, which is 0.06 divided by 12. How we got 12? This because in this question, it mentions compounded monthly, so it must be 12. For R1, we get 292 ringgit 17 cents, and for R2, we get 442 ringgit 70 cents. For N, we must use 7 multiplied by 12, and we get 84. And in these questions, we use formula A equal to R. So here we use formula A, which is A equal to R, bracket 1 minus 1 plus I, bracket negative N, divided I. In this question, we must use R2 because we want to know how many years that we can shorten the loan. So here, we want to find N. So we put A here, which is 20,000, equal to R2, which is 442 ringgit 70 cents, bracket 1 minus bracket 1 plus I, which is 0.06 divided by 12, bracket negative N, bracket, divided again with I, which is 0.06 divided by 12. So the next step is we need to move R2 into the left, and we need to solve the problem in the bracket 1 plus 0.06 divided by 12. So it will be 20,000 divided by 442 ringgit 70 cents equal to 1 minus bracket 1.005 bracket negative N bracket divided by 0.06 divided by 12. When we get the answer for 20,000 divided by 442 ringgit 70 cents, we need to multiply with 0.06 divided by 12. How we get that? Because we move 0.06 divided by 12 to the left, so it will be multiplied. So the next step will be 45.2314729 multiplied with 0.06 divided by 12 equal to 1 minus bracket 1.005 bracket negative N. So we get the answers 0.2261573 equal to 1 minus bracket 1.005 bracket N. So we need to move 0.2261573 to the right, and we need to move bracket 1.005 bracket negative M to the left. So it will be bracket 1.005 bracket negative M equal to 1 minus 0.2261573 Then we will get bracket 1.005 bracket negative N equal to negative 0.7738426,397. So the next step is we want to find the N. When we want to find the N, we need to use the log. So it will be negative N equal to negative log 0.7738426,397 divided by negative log 1.005, and we will get the answers N equal to negative 51. Then we need to remove negative. At the two sides have negative, so it will be the answer N equal to 51. Then we use formula N equal to MT, which is 51 multiplied 12, and we get 4.25. Then we want to know how many years that we shorten. So the next step is 7 years minus 4.25 years, and the answer is 2.75 and equal to 2 years, 9 months. The next question is how much interest that we can save. First, when we want to find the interest, we need to use the formula I equal to Rn minus A. First, you need to find the interest for R1. So, the formula will be I1 equal to R1 and minus A. So, it will be 292 ringgit 70 cents bracket 184 bracket negative 20,000. So, the answer will be 4,542 ringgit 28 cents. After that, don't forget to find interest for R2. So the formula will be interest 2 equal to R2 and minus A. So it will be 442 ringgit 70 cents bracket 51 bracket minus 22,000. So the answer will be 2,515 ringgit 67 cents. Then we need to find the total amount interest that we save. So the formula will be I1 minus I2. So it will be 4,542 ringgit 28 cents minus 2,550 ringgit 67 cents. So the final answer is 1,991 ringgit 61 cents.
Now, we move to question 5. Let's solve this ESB investment problem step by step. Alright, a 26 years old woman deposit 10,000 ringgit into ESB. Then the annual dividend return is 5.15% and compounded yearly. After that, she contribute 2,400 ringgit every year for 8 years. Then she stops contributing but leave the money untouched for another 7 years. So, first of all, we calculate the compound interest on her initial 10,000 ringgit deposit over 8 years. First, we use the formula S equal to P, open bracket 1 plus I, closing bracket, and to the power of N. Alright, then we substitute the values in the formula, which is P 10,000, I 0.0515 over 1, and N, which is 8. So we get 14,944 ringgit 0.25 cent. Okay, next, we calculate the value of her yearly contribution using the annuity formula. The formula is S equal to R open bracket 1 plus I to the power of N, and then minus 1 over I and closing bracket. So we substitute the value in this formula where R 2,400, I 0.0515 over 1, and N, which is 8. So we get the answer 23,041 ringgit 18 cent. Okay, now we add both parts together to get her total ESB balance for 8 years, where 14,944.25 ringgit plus 23,041.18 ringgit. Then we get the answer 37,985.43 ringgit. Lastly, we calculate the amount grow for another 7 years with no additional contribution using the compound formula again, as equal to 37,985.43, which is P open bracket 1 plus 0.10515 over 1 close bracket to the power of 7. And the answer we get is 53,986.11 ringgit. Alright, done.
In conclusion, both compound interest and annuities are important financial concepts that helps us understand how money grows and how payments work over time. Compound interest shows how savings or loans increase because the interest is added on top of previous interest, leading to faster growth. Meanwhile, an annuity also involves making a regular payments either by saving money or paying off a loan over a fixed period. By understanding both concepts, individuals can also plan their finance better, make smarter decisions, and also achieve future financial goals more effectively.